Hello viewers, Swagdaruna taking you through the story for A-level pure mathematics. And in this video, we're going to go through the marking guide for Senior 5 Math 1 end of Term 1 for the year 2024. So this video is suitable for students in both Senior 5 and Senior 6 offering principal mathematics as part of their combination. So these are the papers we hope to upload. What is strict is already available on the platform, and today we are to go through the math paper 1 for Uganda Matters Namugongo. And I still remind you of the books you'll need in this A-level. So principal mathematics, there are 4 books: Math Paper 1, Math Paper 2, Topical Question Bank, and Termly papers with their marking guides. For subsidiary math, it is only 1 book having all notes, Termly papers with marking guides, and U.A.C.E papers with marking guides. Physics, there are also 4 books: Physics Paper 1, Physics Paper 2, Topical Question Bank, and its solutions. For any of the copies, contact the author on this contact. So shall start with question 1. Question 1 says, a strand of wire of length 32 meters is cut into 2 pieces. One piece is bent to form a rectangle whose length is 2 meters more than the width. Okay. The other piece is bent to form a square. The total area enclosed by both the square and the rectangle is 31 meters squared. Find the perimeter of the rectangle. So you need to make a sketch. They said the length is 2 meters more. So if the width is x, length will be x plus 2. Then the other wire is used to form a square. That means the total length will be equal to the perimeter of this plus the perimeter of this to give you 32, which is here. So one is to simplify and express one unknown in terms of the other. So open brackets, collect like terms, you can reduce the expression, then I can make y the subject. Then about total area, they also told us total area enclosed by both square and the rectangle is 31 centimeters, 31 meters squared. So area of this plus area of this must be equal to 31. So this is the area of this, and this is the area of the square. Add them, you'll come up with 31. So that means I can substitute for y. And open brackets, expand this, I'll come up with this. Then I will collect like terms. This with this, this with this, then this with this. That is now a quadratic which can be solved. So now let's see how to solve the quadratic. You can use the quadratic formula and get the 2 values of x. Then when perimeter is given by that expression, so when x is 1, so how did we get this? We know that width is x and length is x plus 2. So perimeter is 2 into brackets length plus width. So this plus this gives you 2x plus 2. Factorize out 2, you come up with 4 into x plus 1. Therefore, when x is 3, come and put 3 here. You'll come up with that. And when x is 1, you'll come up with that. And that's what they wanted. Then question 2 says, a rectangle ABC with vertices these ones, find Roman 1 the equation of the perpendicular bisector of AB, and Roman 2 the equation of the altitude from A to BC. So one, we need to make a sketch. So the sketch will somehow, the positions were somehow accurate, but even if they are not, it is still okay. So this is horizontal because y coordinate here is the same as y coordinate here. And this is vertical because x coordinate here is the same as x coordinate there. That's why I made this vertical and this horizontal. Then they told us, so they want a perpendicular bisector. Let D be the midpoint. So a perpendicular bisector will be passing through point D and it will be perpendicular to AB. Then for the altitude of A from BC, from A to BC, it means that you stand at A and you drop a perpendicular to meet BC. Then they want the equation of that line AE. So let's start with the equation of the perpendicular bisector which passes through point D. The first thing to do is to get the midpoint. Midpoint is the average of the coordinates. So 2 plus 2 over 2, 6 plus 3 over 2 to give you this as the midpoint. So this should be point D. Then the gradient of the perpendicular bisector is equal to -1 over gradient of AB. That's the condition for perpendicular lines. So when I substitute, that means that here I'll get negative of change in x over change in y to give you 0 as the gradient. So now that I know the gradient, I can get the equation of the perpendicular bisector, which will be that. I can simplify to get that because 4.5 is the same as 9 over 2 cross multiply to get 2y equal to 9. It is the same. Then the equation of the altitude. One, I need to first get the gradient of AE. They are also perpendicular to BC. So I use the condition for perpendicular lines and substitute. Negative is here. Then change in x over change in y to come up with 1. So I have a gradient and I have a point. So I can get the equation of the altitude, which will be that. And that's what they wanted. Then question 3 says, given that tan A is this and sin B is that, where A is reflex and B is an obtuse angle, find, without using a calculator or mathematical table, the value of this. So one, we need to get sin A and also get tan B. The first thing to do is to identify the quadrant. For obtuse, it means that B is in the second quadrant. For reflex, it means it's either third or fourth. But because tan is positive in the third quadrant, it means that A is in the third quadrant. So I'll come and draw a quadrant for A and also the quadrant for B. So by Pythagoras theory, this hypotenuse is 5. Then quadrant for B, it's in the second quadrant. So by Pythagoras theory, I come up with that. So that means that a sine is negative in the third quadrant, so that's why it is negative opposite over hypotenuse. Then tan B is negative in the second quadrant, that's why it's negative opposite over adjacent. Then I can substitute in the expression given. So sine tan to come up with this, which is equal to 4. And that's what they wanted. Question 4 says differentiate this from first principles. So we shall let y be equal to that given expression, then increment both sides. Where there is y, you put there now y plus delta y, small change in y. Where there is x, you put there x plus small change in x. Then next is to take this one, this side. When you take it that side, it becomes this. Next is open brackets. So open this bracket to give you this. Then open this bracket to give you this. Then I'll have to collect like terms. So when I open this bracket further, I'll come up with this. Then I'll bring also this one here. Then I'll say I remain with only these fractions. So that marks for this slide. This is for the next slide. We shall now get the LCM of the fraction and combine the two fractions into one quotient. Then we shall simplify this x and this cancels to remain with only small change in x. Now you realize that there is at least small change in x in each term, so I need to factorize it out. After factorizing it out, I can take it this side to get small change in x or small change in y over small change in x. After succeeding to get this, next is to remember the definition for dy dx, which is equal to limit as small change in x tends to 0 of this. So that means that where there is small change in x, you put there 0. And you simplify. So this is here. The whole of this has become 0. And here we shall remain with x squared as the denominator. And that's what they wanted. Question 5 says, solve this for values of theta ranging from 0 to 360 degrees. So given that, we shall change this in terms of sine and cos. Then we can cross multiply, take this side to give this. Now from here, the mistake students do is to cancel here. So in trigonometry, we don't cancel ratios. We only take everything on one side and factorize. So I needed to see you take everything on one side and factorize. That means that this is equal to 0 or this is equal to 0. This is a square, so you put square root on both sides to get plus or minus. Therefore, for sine theta equal to 0, these are the angles, and for cos theta equal to plus or minus root 3 over 2, these are the angles. And that's what they wanted. So this A1 is for this, then another A1 is for the angles of theta for positive, for cos, where cos is positive, and cos is positive in the first and third quadrant. Then next is angles of theta where cos is negative, and cos is negative in here and there. Then question 6 says solve for x, and given that. So the first thing to do is to let y be equal to this. So that means we shall come up with 9y plus 4 to power negative 4y power negative 1 equal to 37. This one is the same as this. Then we shall multiply followed by y and rearrange to get a quadratic. Then we shall use quadratic formula to get the two values of y. For each value of y, we have the corresponding, but we know that y is equal to this, so replace y with that, replace y with this. Then get the value of x. That means that we shall multiply both sides by the reciprocal of the index. So this is 2 over 3, so there should be a power. Put a power of 3 over 2. 3 over 2 here, power of 3 over 2 here. That's why you see here 3 over 2. Then also same applies to this, put the power of 3 over 2 here. Then you can get the values of x which they wanted. Then question 7 says, show that this minus this is equal to this. So first of all, we are going to remember here there is no side, which is okay, but here the denominator has a side. So the first thing to do is to rationalize. So multiply by this, both numerator and denominator. Then you try to expand it. So this with this gives you x square root of x squared y. This with this gives you y times square root of xy. And this is difference of two squares, meaning square of this is x, square of this is y squared. Okay. Then here, this squared can come out to become x, so x root y. Then also here you realize that this one we factorized out y because y was common. So it became y in brackets x minus y squared. Now here the LCM will be this because this factor is already the same as here. So I will combine them into one quotient. So LCM is this, meaning that you get this, which is here, the first two. Then these ones you have to multiply by y. That's why you see a y times this. Then open brackets. This is the same as this. But when I open brackets, this times this, I'll come up with this. Then this times this, I'll come up with this. Then I realize that this one and this can cancel, so I remain with this and this. Denominator remains the same. Then from there I realize that root square root of xy is common. So factorize it out to remain with x minus y squared, which is also similar to the denominator, a certain term in the denominator. So I'll cancel this and remain with this over this. Okay, now this one is the same as square root of y squared. Then I'll put both under one square root to give you this. Then I realize that one y can cancel with this to remain with x in the numerator and one y in the denominator. And that's what they wanted. Then question 8 says, given that XYZ is a triangle with vertices this, and M and N are midpoints of XY and YZ respectively. So here there should be a word respectively. Verify that angle XYZ is a right angle and also that MN is parallel to XZ. So one, we need to make a sketch of a triangle XYZ. Then you put the midpoints M on XY, then N on YZ. Then we join the two points. Okay. So one, they want us to verify that angle XYZ, this angle, is 90 degrees. Therefore, we shall use dot product. The direction vectors we use matter. The arrows must either be diverging or converging. So I expect to see vector yx, which is diverging, and also vector yz, which is also moving away from a common point. So those are the vectors I will dot. So if I use xy and here I use zy, if I use yx and here I use zy is not okay. The arrows, the vectors must be either away from a common point or towards a common point. So now that I've got vectors, I'll come and dot. So dot these two vectors. This times this is negative 20, then this times this is positive 20, which gives you 0. So because the dot is 0, it implies that the angle XYZ is 90 degrees. The next was to show that MN is parallel to XZ. So I'll need to first get XZ, which is there. Then I'll also get MN. So what is M? M was the midpoint of XY. So it's good by getting the average of the two vectors, which is that. Then also ON is the midpoint of YZ, so you get the average of the two vectors to give you this. So I have OM and ON, so I can get now MN. Therefore, I come here and get the vector MN, which is ON minus OM. Then I'll now compare, because for parallel vectors, this must be a scalar multiple of the other. One must be a scalar multiple of the other. So I can quote this, then substitute for XY, XZ, and MN. Then I find out whether K is constant or K is a scalar. For the first row, K is 2. For the second row, K is still 2, meaning that K is a scalar. Therefore, I can conclude that XZ is equal to 2MN, implying that they are parallel. So that brings us to the end of this video. Thanks for watching, and be reminded the next video will be on Math Part 2 end of Term 1 still for the same school. So if you have not yet subscribed, please click on the subscribe button below this video so that I can receive updates when the next video has been uploaded. And also, if you know of any student who is not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp so they can all benefit as a family.